The petrochemical industry.
What are petrochemicals? In the basic sense, petrochemicals are chemical products derived from petroleum. Some chemical compounds can also be made from other fossil fuels, such as natural gas, coal, and renewable resources like that of corn and sugarcane. The largest petrochemical industries are here in the United States and in Western European countries. However, there has been a major growth in the production in the Middle East and Asia. The two common classes of petrochemicals that we will be examining are olefins and aromatics. The first class of petrochemicals we will look at are olefins. Olefins are unsaturated hydrocarbons, meaning that they only contain hydrogen and carbon atoms and have at least one double or triple bond in their structure. They are used in the basis for polymers, creating plastics, resins, fibers, lubricants, and gels. The annual production of olefins are upwards of 100 million tons. The two forms of olefins include ethylene and propylene. Ethylene is a colorless gas which has a faint, pleasant, sweet smell. It is very reactive and flammable. It is the simplest form of alkene with its hydrocarbon structure of 2 carbon atoms and 4 hydrogen atoms. It does not dissolve in water, but often mixes well with most organic solvents and is known as a volatile organic compound. It is naturally released by plants and living organisms, while it is also present in exhaust fumes and pollution. Ethylene is commonly mixed with other compounds to create a variety of useful purposes. The first mention of this gas was made by Johann Beecher in a late 1600s publication. Ethylene, being the simplest form of olefin, is often transformed into its common subgroups: polyethylene, created through polymerization, ethanol, created through hydration, and ethylene oxide through oxidation. Ethylene is produced worldwide with over 100 million tons annually. That is higher than any other organic compound. It is produced in chemical plants through steam cracking processes. The major reactions ethylene interacts with include polymerization, oxidation, halogenation, hydration, and more. Majority of ethylene production goes into creating polyethylene. It is the main ingredient of many types of widely used plastics and synthetic rubbers, including paints and other coatings. It is also used to make other products such as antifreeze and detergents when it has undergone oxidation. The best known effect of ethylene is the stimulation of fruit ripening, while it also increases respiration, yellowing and spotting, reduction in nutrient content, taste and aroma changes, and loss of leaves and flowers. The effects of ethylene on plants can be slowed down when kept at lower temperatures. The gas is able to penetrate most substances, including the shipping boxes and wooden crates that the produce is normally distributed in. Overexposure can be harmful to the produce as it causes premature decay. However, it is not harmful to humans.
Propylene is the other form of olefin. It is an organic compound that is a vital basic chemical in the petrochemical industry. Alkenes, interchangeable with olefins, is a class of unsaturated hydrocarbons that contain at least one carbon-to-carbon double bond. In its pure, natural state, propylene is a colorless gas with a weak but pungent smell. It has a melting point of 185 degrees Celsius and boiling point of negative 47.7 degrees Celsius. It is also highly flammable and relatively stable. However, propylene reacts like typical alkenes by opening up its double bond. The polymerization of propylene yields the polymer polypropylene, a plastic used in the petrochemical industry widely as packaging, labeling, textiles, and various other applications. Propylene also oxidizes to produce acrolein. In the presence of excess or insufficient oxygen, propylene combusts to form water and carbon dioxide. Finally, the addition of halogens results in a halogenation reaction as well. The primary source of propylene is from cracking naphtha and other liquids, such as gas oil, condensing to produce both ethylene and propylene. The cracking of liquid feedstocks is carried out predominantly in Europe and Asia, but less so in the Middle East and North America. A growing source of propylene, particularly in the U.S., is from refineries where splitters recover it from the off gases produced by fluid catalytic cracking. However, refinery propylene needs to be purified for both chemical and polymer use. With propylene demand growing faster than ethylene, on-purpose technologies are being employed increasingly to make more. The main on-purpose process used is propane dehydrogenation, or PDH, in which propane is converted to propylene at 500 to 700 degrees Celsius in a reactor containing a noble metal catalyst. In a market study, nearly 85 million tons were processed in 2013, with the majority being in China, the United States, and Western Europe, which has been consistently producing over 14,000 kilotons a year, as shown by the production chart. Propylene has virtually no use as is, but instead is an important raw material used in the production of other organic chemicals such as propylene oxide, cumene, acrylic acid, and glycerin. Polypropylene is applied to a variety of fields for its relatively low cost and excellent rigidity, heat resistance, and gloss, and therefore is produced in high volumes and actually accounts for about 2/3 of propylene demand. The polymer's main applications are in the production of films, packaging, electrical appliances, wire, and is the plastic utilized in 1/3 of automobiles. In industry and workshops, propylene is used as an alternative fuel to welding and cutting, brazing and heating of metal for the purpose of bending. There has also been interest in using propylene as the main component in rocket engine fuel.
Aromatics are the second main class of petrochemicals. They are typically ring-shaped molecules which make them unusually stable. The term aromaticity is used to describe these structures. They typically have alternating single and double bonds in the ring. This also makes them difficult to break apart or react with other substances because they are quite happy with their structures. Aromatic compounds also play a key role in the biochemistry of living organisms. In this presentation, we will talk about 3 of the main subgroups of aromatics in the petrochemical industry. Aromatics can also be referred to by the acronym BTX, which stands for the main subgroups in the petroleum industry. They are typically produced from the catalytic reforming of naphtha. Benzene has the molecular formula of C6H6 and a molecular weight of 78.11 grams per mole. This organic chemical compound is classed as a hydrocarbon and is a natural constituent of crude oil. It has very distinctive properties and is used as a precursor in the manufacturing of more complex chemicals. It was first isolated and identified by Michael Faraday in 1825 from the oily residue derived from the production of illuminating gas. Although its molecular formula was known, many scientists were initially confused on how the structure of benzene was organized. Its ring formula was then discovered by Auguste Kekule, who realized the structure after daydreaming of a snake chasing its own tail. Benzene had many early uses before its toxicity was well known, including being used in school laboratories which exposed students to the chemical. This practice is almost now eliminated. Benzene is a highly in-demand product. It is primarily produced in Asia, Western Europe, and America. It is found in petroleum and coal, but is also a byproduct of incomplete combustion. There are 4 specific processes to benzene production. Catalytic reforming is a petroleum refinery process in which low-octane products of catalytic cracking are reformed into higher-octane ones, such as gasoline, under high pressure and temperature and in the presence of catalysts. Toluene hydrodealkylation converts toluene to benzene. Toluene is mixed with hydrogen and then passed over a chromium or platinum oxide catalyst. Sometimes higher temperatures are used instead of a catalyst. In toluene disproportionation, 2 toluene molecules are reacted and the methyl groups rearranged from one toluene molecule to the other. This yields 1 benzene molecule and 1 xylene molecule. Steam cracking can produce a benzene-rich liquid byproduct called pyrolysis gasoline. Pyrolysis gasoline can be blended with other hydrocarbons as a gasoline additive or routed through an extraction process to recover BTX aromatics. In present day, Benzene is typically used as an intermediate to make other chemicals. More than 50% goes to produce ethylbenzene, 20% to manufacture cumene, and 10% goes to produce cyclohexane. Benzene is also used as an additive in rubbers, lubricants, dyes, detergents, drugs, explosives, and pesticides. As the US is phasing out leaded gasoline, benzene is making a comeback as a gasoline additive. It increases the octane rating and reduces knocking, which is an explosion of the air and gasoline mixture. Benzene is, however, limited to less than 1% by the Environmental Protection Agency due to its toxicity and the fear of it entering our groundwater systems.
Toluene occurs naturally at low levels from crude oil and is usually produced in the processes of gasoline via a catalytic reformer, and an ethylene cracker or making coke from coal. It is widely used in industry, often as a substitute for benzene. Chemical formula C7H8, containing 7 carbon atoms, 8 hydrogen atoms, and a molecular weight of 92.14. It's a petrochemical classified under aromatics along with benzene and xylene isomers. Toluene is classified under this category because the physical characteristics of the compound are as follows. Colorless liquid with a sweet pungent benzene-like odor, it is considered very aromatic. Toluene has 15 sigma bonds, while benzene only has 12 sigma bonds. The difference between the two comes from the fact that a sigma bond between a carbon atom and a hydrogen atom has been replaced by a sigma bond between 2 carbons. Toluene is a methyl derivative of benzene. All carbon atoms of benzene are sp2 hybridized, while the carbon atom of a methyl group is sp3 hybridized, bonded with 3 hydrogen atoms and 1 aromatic carbon atom. The carbon-carbon bond length is almost similar like in benzene, hence an intermediate value of a single and double bond and carbon-hydrogen bond length. Toluene exists in all physical states: gas vapor, liquid, and wet solid. It has a flash point of 40 degrees Fahrenheit, a boiling point of 232 degrees Fahrenheit, and a melting point of 139 degrees Fahrenheit. It is less dense than water, weighing 7.2 pounds per gallon, and is insoluble in water. Alternative names for this compound consist of methylbenzene, anisine, and phenylmethane. Toluene has numerous commercial and industrial applications. For instance, as a solvent in paints, lacquers, thinners, glues, correction fluids, nail polish remover, and is used in the printing and leather tanning processes. Toluene can be used as an octane booster in gasoline fuels, used in internal combustion engines. Absolute toluene can even be used as a fuel for both 2-stroke and 4-stroke engines. Aside from toluene's many helpful uses, toluene can be extremely toxic to humans. It targets the central nervous system. The side effects can be fatal and very harmful. It may cause irritation of the eyes, respiratory tract, and skin. Repeated or prolonged contact with the liquid may cause removal of natural lipids from the skin, resulting in dry, fissured dermatitis. Low-level chronic exposure, as well as acute exposure to toluene, may result in central nervous system depression and decreased memory. Other minor symptoms include headaches, dizziness, fatigue, muscular weakness, and drowsiness. The rate of polluted gases in the atmosphere comprises of dissolved organic compounds, which affects the environment apparently. One of the best methods to reduce harmful gases in the environment is bioreactors. The bioreactors are abundantly used to degrade those substances depending upon various parameters and suitable materials like packing material and microbes. One such dissolved organic compound, which is highly toxic to human beings and also present in the gaseous state, is toluene. A bioreactor is a vessel in which a chemical process is carried out. This process can be conducted either aerobically or anaerobically. These bioreactors are commonly cylindrical, capacity ranging in size from liters to cubic meters, and are made from stainless steel material, such as air compressors and oxygen tanks. When a spill or leak of toluene occurs, there are several treatments the industry uses to fix the problem. Treatments used are physiochemical treatment methods, biofiltration, biodegradation, thermal oxidation, and catalytic oxidation. All these biological treatment methods can convert toluene into carbon dioxide, water, salt, or biomass, having a safe cleanup.
Xylene is a subset of aromatics, and like many other aromatics, xylene is a colorless liquid with a strong sweet odor. However, most of the time, xylene is known as three main isomers: orthoxylene, metaxylene, and paraxylene. Some background information for xylene is that it was first isolated and discovered by August Cohors in 1850 after it was discovered as a component of wood tar. An alternate name for xylene is known as dimethylbenzene due to the change in chemical structure of various methyl group on the benzene ring. Xylene is an aromatic hydrocarbon and is known to be a flammable liquid that can be moderately soluble in water. It ranks as one of the top 30 major petrochemical when considering volume distribution. Some interesting facts about xylene is that it's the second highest aromatic product, ranking behind benzene and ahead of toluene. Majority of the time, products are composed of a mixed xylene, a blend of the three isomers and the other products like ethyl benzene. The most abundant of the xylene isomers would have to be metaxylene, but because of its abundance, the value of this particular isomer makes it less valuable. Over the recent years, paraxylene has been a popular isomer used, but mixed xylene still remains as the widely used xylene out there, especially in Asian countries. The Asian market, with its large population, growing demand for polyester fiber and polyester resins, and corresponding growth in the polyester industry, is solidifying its position as the center of influence for the mixed xylene market. Although the biggest producer of xylene to this day has to be ExxonMobil Chemical due to its worldwide locations and productions of petroleum products using xylene. Xylene has many uses as a solvent. It can be used industrially by chemical and petroleum manufacturer, polyester manufacturer, manufacturer of paint, dyes, and lacquers, or it could be used in domestic products such as aerosol paint, architectural coatings, automobile and machinery paints and primers, insecticides and fungicides for yard and garden, paints, varnish and paint varnish removers and thinners, pesticides, shoe polish and primers, sealants, and wood office furniture. However, the difference in the isomers play a role in the uses because metaxylene and paraxylene are natural occurrences in petroleum, while orthoxylene is found in coal tar, petroleum, forest and bush fires, and plant emissions. Most of these sources of xylene ends up releasing the chemical into the air, contaminating and exposing this hazardous chemical to many people. A high-level exposure of xylene to a person can cause dizziness, passing out, and death. There are a few ways that xylene can be exposed to the person. The main exposure of xylene to many people is from petrol, automotive exhaust, or just using everyday domestic products that contain xylene. When used in a room with little ventilation, it is easy to succumb to the symptoms xylene can cause. However, since it is used in many consumer products, short-term exposure is considered safe. Workers that are continuously exposed to xylene can damage their neuropsychiatric permanently. When exposed to xylene, the skin, eyes, and respiratory tract can become irritated due to it most likely being inhaled. Symptoms of xylene poison can range from CNS effects, ventricular arrhythmias, acute pulmonary edema, respiratory depression, nausea, vomiting, and reversible hepatic impairment.
Overall expansion of the population and an increase in individual purchasing power have resulted in an increase in demand for finished goods and greater consumption of energy in China, India, and Latin America. As both energy and chemical markets compete for hydrocarbon molecule demand, fluctuations in energy demand can controversially affect petrochemical market vitality. Lower crude oil prices and lower energy consumption will lead to higher petrochemical demand and vice versa.
As stated before, chemicals derived from petroleum or natural gas are petrochemicals, which are essential to today's industry. Petrochemistry is a fairly young industry that only started growing in the 1940s. During World War II, the demand for synthetic materials caused the petrochemical industry to develop into a major necessity in today's economy and society. Petrochemicals do not reach the final consumer. They are sold into other industries so that they can undergo transformations to create the products that seemingly bear no relation whatsoever into the initial raw material. The environmental movement spawned in the 1960s and 70s led Americans to be wary of industries that pollute. The industry slowed but was not stopped. In the 1980s and 1990s, it was largely restructured, and the major petrochemical companies such as Shell and Mobil created company mergers to strengthen their marketplace.